This is Steve Smith, Director of the Virtual Lab. I'm joined here in beautiful downtown Silver Spring at the VLab studios by the production manager, John Chattel, and logistics, all-around VLab Forum logistics guy. This afternoon, we have the pleasure to have a presentation entitled An Introduction to the National Blend of Global Models project, to be presented by Catherine Gilbert, who is currently Acting Director of the Weather Prediction and Ocean Prediction Centers Deputy Director, thank you, of NCEP, along with Dr. Dave Myrick of the Meteorological Development Lab. To remind everyone, this presentation will be recorded and uploaded to the VLab Forum website shortly after the conclusion of the forum. Our format is 30 minutes of content presentation followed by question and answers. We ask that you provide your questions using the raise your hand feature of the GoToMeeting at any time, and we will unmute you for you to ask your question verbally. If that's not an option, you can also use the chat feature and ask a question through that of the chat feature of the GoToMeeting, and John Chattel will read your question to the audience through that chat feature. So without further ado, I'll hand it over to Kathy Gilbert.
All right, thanks, Steve. So today, the material I'm presenting has been presented a few times to some of the students out in the regions, and some of this material was presented at the AMS meeting. So for some of you, it might be review. Hopefully there are some that you've learned something today. I want to acknowledge our co-authors here. These are the team leads for this project. So Jeff Craven, Dave Novak, Tom Hamill, Jim Seebeking, and David Ruth. So go ahead and get to the next slide. So today, the topics I'm going to cover are the project goals and the scope, some of the current activities and the progress we've made so far on this project, our schedule, and a summary of our issues and challenges. And then Dave Myrick is going to split the presentation with me, and he will give some examples on how we're using the VLab to support this project. Okay, next slide. So I think everyone recognizes that we have a growing challenge in the Weather Service, which is consistency. So local forecast offices are working primarily to serve local user requirements, but how are the state, regional, and national needs being addressed? Inconsistencies across the CWA or regional lines lead to challenges for impact-based decision support services on the state, regional, and national scale. So what do our partners think when they see these sharp changes in the forecast grid? Well, we know it impacts their confidence in our forecast. This issue has nothing to do with the products and services the WSOs provide to the local users. That role is critical, and it keeps the NWS relevant. But consistency becomes an issue along CWA, state, and regional boundaries. So let me describe a little bit about the origins of this project. So a variety of regions and offices have been looking into ways to provide a better starting point. But it's not efficient to run this at all 122 WSOs. The NAPA report recommends that we need to facilitate consistency and sharing of information because of the lack of consistency is impeding the ability of our partners to use our data. The Weather Ready Nation Roadmap highlighted plans to proactively adopt new science and technology developments and leverage field innovation to enhance services. Well, the Sandy Supplemental Project came along with a large chunk of money available for mitigating the potential gap in the POSE data in the Joint Polar Satellite System. A variety of great projects were proposed and funded to mitigate the impacts of potential gaps, both at the Weather Service and at NSF. The Central Region Model Blend was one project that was an example of a better use of existing model data to mitigate this potential gap. So along came this national project to incorporate the idea of model blending in a national way, and it was funded as a way to explore expanding that tool across the country while ensuring it is a top performer. Okay. So here is an outline of the team structure. So up until January, Stephen Lord was the technical advisor to this project. So if any of you were involved in the beginning, you may remember Steve Lord leading a lot of these early discussions. I took over as project manager, I guess it's been a little over a year ago, and Dave Myrick has been brought on board recently, and he's now serving as the Deputy Project Manager. We have plenary teams represented from Weather Service Headquarters, NSEP, Weather Service Regions, NUISIO, and OAR. We have 5 main working level teams. So we've got the Analysis and Verification team, which is led by David Ruth. We have a Post-Processing team that's led by Tom Hamill. Testing and Training, which is led by Dave Novak and Jeff Craven. And we have a Dissemination team that Jack Settlemeyer and myself, are working on. And then finally, we have an Outreach team that Jim King and John Gagan are involved in. And the Outreach team feels it's very important that this project is communicated effectively with the people that will actually be using the new guidance product. So today I'm going to talk mainly about the analysis and the verification efforts and the post-processing efforts. And then we'll also have Dave Novak talking a little bit more about how the VLab is used in some of the outreach projects. The objective of the project is to improve quality and consistency of the National Weather Service National Digital Forecast. So through an integrated and structured approach, we'll develop a set of foundational guidance products for NDSC weather elements that's based on both weather service and non-weather service model information. We want to create a methodology for the national blend, or our best product, from multiple models. We're going to focus initially on the days 3 through 8 time frame, but we want to build a system that's extensible to a full set of deterministic probabilistic products covering days 1 through 10. So when we started the project, we recognized we needed an enterprise solution, so we want a nationally uniform product with spatial and temporal consistency. It needs to be extensible so that in the future we can add more models, we can add more weather elements, and we can expand on the lead times. And it needed to meet R2O criteria, so we needed to have projects that were ready to be implemented and we could sustain. And then, of course, we want no degradation in service. Okay. So we want to be clear on what the project is and what it is not. So it is a recognition to get the most out of the data we have and use it to improve consistency in products on a state, regional, and national scale. We want it to be a scientifically sound approach to extract consistent weather information from all models, especially the ensembles. It is not a way to reduce staffing, and it is not a way to remove the human completely from grid editing. Okay. For the project development scope, we agreed to focus on the NDSC weather elements. So we're going to do this in phases. So for version 1, in December 2015, we expect that we will be generating temperature, dew point, max and min, sky cover, wind speed direction, and probability of precipitation. So when I say version 1, December 2015, it's our goal to have these running reliably in the production environment on WCOS, and then get those disseminated out to WPC and the WFOs. For version 2, later on in FY16, we want to add snowfall amount, QPF, wind gusts, precipitation type, and predominant weather. And where we can, we'll derive fields like apparent temperature and relative humidity to ensure consistency. Okay. These products, as I mentioned, will be generated on WCOS, so they'll be generated on the supercomputer in the production job stream. We are focusing on the global models because our initial efforts are going to look at the medium range, the days 3 through 8. So today we are calibrating, post-processing, inputting ECMWF deterministic and ensemble model data, the GFS deterministic and the GEFS ensemble data, and the Canadian ensemble data. We started processing the Canadian deterministic. I'm not quite sure that we're doing anything with that yet, but we're building an archive up for that. We had looked at the Navy models, but they've changed from the NOGAPs to their NavGem recently, and we didn't have any training data for that, so we haven't done anything with the Navy model yet. And we may eventually be able to bring in the UK map model.
Could you back up one slide? Just one quick follow-up question. You may have mentioned this, I'm sorry if I missed it. On version 1 versus version 2, what are the delivery times? Is 0Z only, 12Z only, both?
That's a good question. So we plan on implementing 2 cycles. So we will have models that run after the 0Z model data is available, and we'll have a blend that runs after all the 12Z guidance is available. So,
and that's for both version 1 and 2?
correct. So we will start out running twice a day. There are still some questions that the team is tackling about what are the best 2 times a day to run, whether or not we want to run with the latest GFS, which might mean using an older ECMWF, or whether we want to wait for the latest ECMWF ensembles to run. So we haven't quite solved that yet, but we do know we need to do this at least twice a day. Okay. Go ahead. So here's our vision for an implementation plan. So we will run them on WCOS using calibrated post-processing methods twice a day. You jumped me a little bit there. We are initially limiting this to the global models, so both deterministic and ensemble global models. In future enhancements, we'll look at the mesoscale models and focus more on the early time periods. That's not part of the scope of the Sandy Supplemental Project. This objective guidance, the national blend that's coming off the WCOS, will be disseminated both to the NSIP centers and the WFOs. Because it does have European model data in it, it is restricted. That data will be encrypted, but that data will go to both the WFOs and NSIP. So then NSIP will provide oversight, the Weather Prediction Center specifically, for the national blend for days 3 through 8 to ensure meteorological and spatial consistency. So then the WFOs will get both that objective guidance running on WCOS, and they'll get the value-added WPC grid. The WFOs are going to retain the final gridded forecast responsibility for the day 1 through 8 periods of populate NDFD. And so the time frames might seem a little bit inconsistent, but on WCOS we can generate the objective guidance from days 1 through 8 or days 1 through 10. So we can post-process model output through the entire cycle, but we're only guaranteeing, I guess, the meteorological consistency, the oversight from WPC for days 3 through 8. So I'm going to turn it over to Dave Myrick now to talk about some of the specifics of the team's work.
Thanks, Kathy. First, I'll focus a little bit on the work of the analysis and verification team that's been led by Dave Ruth. Here at MDL, we've developed a viewer online that allows us to compare the performance of different candidate analyses as well as the prototype blends that we've been developing in real time with the NDFD. At first, the analysis and verification team focused most of its efforts on comparing candidate analyses. What was determined was the best solution for this project was to focus efforts on the real-time mesoscale analysis and the unrestricted mesoscale analysis, or the IRMA. Why the group decided on this? Well, this option runs centrally on WCOS. It's available for all of the NDFD domains required to create blended products for this project. Because of this, an effort was started to improve the RTMA and IRMA. A lot of resources went into this over the last 6 to 9 months. The group over at EMC has really done a great job, and they're in the process of upgrading the RTMA. There'll be a 30-day NCO test for this coming up basically over the next 5 weeks or so, and they're hoping to get this implemented in late March or right around the 1st of April. The viewer that MDL put together was a very helpful tool in the evaluation of the changes to the RTMA. All of these fields are out there and available for folks to take a look at. Next slide. This is an example of the viewer that MDL put together. And as a part of this evaluation of the RTMA this fall, EMC was considering 2 different versions of the RTMA, one that used a blended background field, a combination of the HRRR and the NAM-CONUS nest. And then they were looking at a version that only used the HER as a first guess. And so there were folks in the field, folks here at MDL and at EMC that used the viewer to compare the two so that a determination could be made on what would be implemented. The larger group decided to implement what's being called the IRMA blend, the analysis on the upper left. One of the challenges that we did notice, however, was the blending together of two different analyses to create wind fields. And so as a result, what was decided was that a blended first guess between the HER and the NAM nest would be used for all of the elements except the wind, and I believe the other one was visibility. The MDL viewer is available to anyone that has an LDAP account, so anyone in NOAA can take a look at it. John, could you really quickly just pull up the page that we had preloaded? Here's an example of the viewer. I'm not going to do a full-blown demo right now. We will send out the URL to this if you don't have it already. We realized right before the call that we had not put the URL of the page in the slide deck, so we'll send that out afterwards. But it's neat. It has a pan and zoom capability. You can zoom in over your CWA. You can compare 4 different sources side by side. You can mouse over, and there's a screen readout in the upper right-hand corner to compare values. And this has been really helpful gaining feedback, evaluating both the RTMA and the new prototype blend product. So, John, if you want to switch back to the slide deck and go on to the next slide. Moving on to the post-processing team, this team is being led by Tom Hamill of OAR. The majority of the post-processing efforts for this project are being split between OAR and MDL. OAR has been focused on the precipitation guidance, specifically the development of POP and QPF guidance. And currently, they've passed off code to MDL for the 12-hour POP. And we're in the process here at MDL of implementing that into the larger system for the model blend. And that data should hopefully be available here in the next couple of months on the viewer. In addition, here at MDL, we're focused more on the non-precipitation fields. The prototype grids for temperature and dew point are already available on the MDL viewer for evaluation. And we're focusing on additional fields that will be a part of Phase 1 to be implemented later this year. The lead for all of this work here in MDL is Bruce Steenheim. Next slide. Here's just another example from the viewer that shows in the lower right prototype blend guidance. This is a 78-hour dew point forecast valid back on January 2nd. And you can see how the blended guidance compared to data from 3 different sources, the NDFD on the upper left, WPC guidance on the upper right, and GMOS grids on the lower left. And it's just an example of some of the comparisons you can do within the MDL viewer. And the URL for the page is on this particular slide on the upper left. Next slide. Early verification work of the National Blend Prototype grids has shown that the grids are comparable skill-wise to other sources of data that are out there. On this particular plot, the National Blend is in the magenta color. This is a dew point verification back for the month of October. One thing to keep in mind, this was verified against the operational RTMA at the time, and there's been a lot of changes and enhancements made to the RTMA over the last 6 to 9 months. These scores should improve once we start running the verification against the new RTMA that will be implemented here in the next 4 to 6 weeks. If you want to move on to the next slide. In addition, one of the 5 sub-teams, the dissemination team, has started to work on getting the prototype grids out and available for folks to look at in AWIPS 2. And we'd like to thank some of the folks at Southern Region Headquarters, as well as Jerry Wiedenfeld at WFO Milwaukee, who have recently started pulling this data into their office and bringing it into AWIPS and GFE. Jerry just ran these verification stats recently and shared them with us. What's on the screen is an MAE plot for temperature over the Milwaukee CWA for a 15-day period this month. And as you can see, the national blend, which is in green, is faring comparable to the official forecasts in blue and forecasts from the Central Region Superblend in red. In this case, they're verifying against the analysis that's running locally in Milwaukee. It's a consensus analysis of different observing analyses. Jerry also verified against the operational RTMA, if you click one more. And you can see that the results for hourly temperature are similar as well. One thing to keep in mind, these are being verified against the operational RTMA, and there'll be some significant enhancements coming here very soon. One thing we did with the National Blend back on January 28th is we changed our scheme so that the National Blend is being bias corrected against the version of the RTMA IRMA that will be implemented in 5 or 6 weeks from now by NCEP. And so it will be interesting to see how the prototype blends fare. We suspect that the verification should improve as that works into the system here in the coming weeks. Next slide. One of the other challenges that was identified by this project is across the National Weather Service, we aren't necessarily using a standard terrain. What the WFOs are using in the GFE versus what the developers here at MDL for MOS and what the developers at EMC were using, everybody was using a different terrain. So the credit for this goes out to Brian Moretsky at Eastern Region SFC. There was a group that was pulled together to come up with a standard terrain field that could be used both in AWIPS and by all the development organizations supporting the field. So work is underway to get these new terrain fields into AWIPS 2. And by later this year, everybody will hopefully be playing with the same terrain, which will help in the development of all of the products and make things a lot more consistent.
So the last one in September, that day was?
Right. We Raytheon got the terrain files, picked them up in December, so they'd be part of the build that comes out in September. So, yeah, Ed Mandel and Raytheon was working with our team trying to get that ready. And it'll be part of the new IRMA RTMA that goes out next fall as well. So our goal is to get them all online at the same time.
Next slide. So just to emphasize this point, it's a little hard to see in this room, but on your screen you should be able to see some differences that were done comparing the WFO terrain that's used in the GFE versus the terrain that was being used by the RTMA. And there were some significant differences between the two, which would obviously lead to some inconsistencies between what's being forecast in the field versus the analysis that would be used for verification purposes. So going forward, this challenge will be resolved with this common terrain, which is very great news.
Excuse me, when you say difference in terrain, what field? What aspect of the terrain? The height?
The actual elevation of the underlying terrain being used. So for example, in the WFOs in the field, their smart inits are using that terrain information to calculate variables from different models, and then they're forecasting, and they may think that the terrain at one location is 500 feet. The RTMA thinks it's 900 feet. That can have a huge impact when you, for example, if you were to use the RTMA to verify that forecast from the WFO.
Because this was, the words on top there say diff greater than 10 degrees Fahrenheit.
We did I had the guys do a quick run of gridded MOS using the GFE terrain, which is what we normally use for gridded MOS, and ran it again doing the elevation corrections using the same terrain that's used by the RTMA. And I had them, with the red triangles, just highlight any places where the differences in gridded MOS were greater than 10 degrees. They only changed the inputs for the terrain files.
I see.
Just a little bit about some of the upcoming milestones. The testing and training team component of this project, they've been working hard to put together a plan for evaluating the prototype products. Development is well underway, and by later this year, the first phase 1 elements will be handed off to NCEP and implemented operationally. the testing and training team has put together a plan that this summer, a subset of WFOs from each of the regions will be provided access to the prototype grids to begin some early evaluation work, taking a look to see how the grids are doing. After the first version 1 elements are implemented operationally, which is scheduled right now for December, beginning in January 2016, we're hoping to open things up so that offices across the country will be able to have access to the version 1 grids and begin looking at these and participate in the evaluation. Later in the year, another round for the version 2 will be implemented and hopefully available by the end of fiscal 15. Since this is the VLab forum, I thought it would be wise to just share a little bit about how we've been using VLab as a part of this project. We have both a VLab community presence as well as a presence on the Redmine development side of VLab. The National Blend of Models is an open community. Anybody can join. There's a handful of links across the top of the page where folks can be directed to our forum, as well as the Google Drive folders for this project where there's tons of information. There's also, our outreach team has developed a Google site which can be accessed if you click on the FAQ button. The one big thing that's been housed in the virtual lab, we've set up a forum to share feedback with the National Blend of Models development team. It acts as a listserv, so if you want to, if you're looking at these and you've put together a little case that you want to share with us, or you have questions, feel free to fire off an email to national.blend.feedback@noaa.gov. That email appears in this listserv forum that we have on Virtual Lab, and then it sends an email to everybody that's subscribed to the forum so that the team working on the project can see your feedback and address the questions you might have. So that's the community presence that we have on VLab. Our primary developer, Bruce Veenheis, is also using the development services, if you click to the next slide. Bruce has a subversion repository where he's managing all of the code for the project. And so that's all maintained and housed on our Redmine development site. As well, we're also tracking issues that need to be resolved. There's a functionality within the development services where we can post tickets and track various issues for the project. So we're leveraging both the community side of VLab as well as the development services side as a part of the National Blend of Models project. One other area that we're looking to leverage this summer as we go into the evaluation stage with 2 to 5 offices roughly from each region is to put together some quick and easy surveys that folks could fill out if they have feedback on the project that would be linked up to the community side of the VLab. We're just starting to learn more about that right now, and we'll share more as we get closer to that part of the project. And I'm going to throw it back to Kathy to take the final summary slide.
All right, thanks, Dave. So I'll just list or talk a little bit about some of the remaining issues and challenges that we are working through this year. So we have been working between Weather Service and ECMWF to come up with a cooperative agreement and then an implementation arrangement that will hopefully ease up on some of the restrictions we've had on these blended products. We don't expect there to be any restrictions on forecasters using this blended output or ECMWF in the line of duty. There's just some questions still about the objective guidance, and that's okay. We can plan on encrypting it and restricting the dissemination to internal use only, but we would like clarification on that. We'd like to get some of this in writing. We recognize the need for nationally consistent foundational data sets, so we're working to get a consistent terrain and land water maps in place, and we're close to having that ready. And we also recognize that there really is an analysis of record in place today for calibration verification, that the RTMA and IRMA is a work in progress. The guys are making great strides to improve it, to get it up to where we need it for calibration. We have been challenged with the lack of high-performance computing, We are hopeful that with the implementation of phase 2 on WCOS that we won't see quite as many outages and we'll have enough disk space to do the work. And we really don't know yet how we're going to blend all of the output. So blending wind direction, for example, or sky cover, that's a challenge. So we want to work with the regions of people that have ideas on how to do this. Bruce certainly has some ideas on how we can pursue this. But we don't have all the answers yet. And then finally, we recognize that there is a high bar in place, a high bar of success for us. The regions have had some successful efforts in blending already, and we can't put a product out nationally that's worse than what they can already do locally. So thank you.
So thanks, Kathy and Dave, for an excellent overview. I'm sure there's lots of questions, so let's go to that part of the forum. So I'll ask John, again, if you have a question, please use the raise your hand feature, and John Chappell will unmute you, or use the chat feature to enter in a question. John, do we have someone?
Nobody's raised their hand yet.
All right, well, while we're waiting, let me start it off, and sort of going back to the beginning, you listed, Kathy, the sort of goals for the project. And the last one was no degradation of services, which is important, but it doesn't sound like a rallying cry for declaring success. So how do you what, in terms of metrics, I'm saying the blend is now improved or done, whatever. What would you put out there is something that would be something to shoot for? And I say this because the HFIP, the Hurricane Forecast Improvement Project, set some very specific goals and worked towards those and made them. And so that was viewed by many as a really good thing to do and essentially drove the project to a success. So what would you call out as something, even if it's not defined yet, what are you looking to say, the blend has done this and here's why?
Yeah, well, I think we have objective measures, like certainly we want to be as skillful as the local blends. That's a goal right now. Maybe less objective, but we need to show completeness of the project. So we're not going to declare that the project is successful until we have the NDFD elements in place and we've covered all of the domains. So we've got to make sure that we can do this for CONUS, for Alaska, Hawaii, for Puerto Rico. So that's another one of our measures, I guess, is that we've completed all of the elements and all of domains, and that we're at least as skillful as the local blend.
Another thing that we're looking for here, this is Dave Ruth, is consistency. So if we can improve the consistency of the NDFD spatially, then I think that's a big plus.
And
there are metrics that you have, Dave, that
they go back 10 years, yeah.
Speak to consistency. So, okay.
Yeah, and Dave Myrick alluded to it a little bit, but Dave Novak and Jeff Craven have been working out evaluation and testing plans. So these 2 to 5 WFOs initially, and eventually more will come on to help. But they're going to be looking at specific case studies, looking at events, how we do in maybe more extreme situations.
Very good. John, do we have?
Yes, Brian Retzke would like to ask a question. He's unmuted.
Go ahead, Brian.
Actually, it's Ken Johnson. Brian is the person that signed in here. I find a discussion about measures of success as it applies to this project kind of interesting. The statement was made that, better consistency. I'm not so sure we've got that really well defined. But I guess my question is, in terms of success, one of the things is you want the forecasters to use it. And I think there's a human factors issue here that has any thought been given to convincing the forecasters that this is the way to go? In other words, this is one of the better tools for them to use in terms of population. In other words, what is to prevent them from just taking this as one more source of guidance to lump in with everything else they consider, as opposed to this being their primary mode of population?
Hey Ken, this is Dave Myrick. I think one of the aspects of the project that we didn't explain in the slides is there is a group, or there is some money set aside. We're going to have, was it 9 total training modules that are going to be involved as a part of this project. And I think that's one of the things that our testing and evaluation team needs to take into consideration as a part of that. The training that we're going to develop for this project is that we need to consider some of the human factors and how we're going to sell this to the forecasters.
Right, and I'll add to that, having the NOISI representative on the team has been great, but it may come down to the end where recommendations are made that we write up our recommendation that these are going to be used as starting points for the grid, but this would have to be negotiated with NOISIO. So it's going to be a joint NOISIO and management decision that these grids are of sufficient quality and they're going to be accepted out in the field.
Okay, yeah, I understand the NOISIO piece, and of course that's an added, could be an added complication. Doesn't have to be, but could be. But I think forecasters kind of know what works for them and knows what's good for them, and I think being able to show whatever measures of success you choose for this, I think you won't necessarily have to sell it. They'll want to use it if it can be presented in the right way.
Yeah, we're seeing it that way too, that if we are successful, we can show that we've got skill, they'll want to use it.
Right.
I agree.
Okay, thank you.
Thanks, Ken. John, do we have...
I'm hoping Kent, I guess, Prochak, can talk. He's got a long question, and I don't want to read it. So.
Kent, are you there?
Maybe not. Okay, well, let me go ahead and try then. So he says, so I see that you have a few of the weather elements as goals, but noticeably the winds are not well done by the blending model, especially by the time the forecast is out in the 3 to 7 time frame. Frontal timing, impact events can be critical. Recently, the GFS, ECMWF highlighted a cold front over Texas along the northern border, and another solution with the front near the coast, with obvious implications for temperature as well. By blending vectors, the output can often become unrepresentative of anything close to the meteorological signs. So the plan gives the okay to blend temperature, but winds are indeed much more problematic. When blending models, it's obviously easy to create smooth fields, but there are times at times not representative of observations. Not representative of observations that would be verified against your example, which was +10 to +9 to -10. Let's see. Certainly, the blends may beat a forecast, improving the quality and accuracy on day 3 to 8 temps with a degree or 2. Should our focus be on impact events, squall lines, snowstorms, etc.?
Wow, I'm not quite sure how to. Well, I mean, he's made a lot of good points, and I think we're recognizing this, that blending wind direction is not something we know how to do right now. We're talking to WPC, we're talking to the local offices on how they are blending wind speed, and Bruce is going to be testing some things out. I don't know that we expect that we're going to be able to, with the blending techniques, hit these extreme events and maybe pick up those kinds of features that you mentioned. I just don't know yet. But certainly those are all good points.
Okay. Do we have any questions in the room?
Could somebody elaborate, please, on how this blending is actually done? Are we talking about using one model's forecast in one situation and another model's forecast for that field in a different situation? Or are we taking 30% of one and 40% of another? And how is that done?
Bruce Meanheis here. So what we have right now in the prototype is basically weighting models based on their recent performance. Specifically, we're tracking the mean absolute error of each model at each grid point. So the recent MAEs are used to derive weights for each model, and then the models are joined using an unequally weighted average of the model forecast. So it's basically a statistical weighting scheme.
So how often are the weights updated?
Daily. So whenever new observations come in this case, whenever new latest IRMA analysis is available, we use those observations and pair them with previous forecasts to update our estimates of the mean absolute error.
Thank you. I've got a question on the evaluation of the analysis, the RTMA and the IRMA. So it's fairly straightforward for me to see how you evaluate a forecast, but it's not altogether clear how one evaluates an analysis. So Dave or Kathy, could you speak a bit towards that?
Sure.
How do you know when the analysis is better than it was before you try to improve it?
There was a lot of work done this fall. A number of issues were identified in the existing RTMA, and we worked closely with the developers over at EMC, shared all those issues. Western region was quite vocal on a number of issues out west, and so those issues were brought to the attention of the developers. They've made a lot of changes over the last 6 to 9 months that will be involved in this next implementation. As those changes were made, we shared the parallel runs with the field, had them look at the RTMA again for similar types of situations, namely cold pools, diversions, problems in the higher terrain over the west. And the feedback that we're now receiving is the changes that were made to the RTMA are an improvement and in the right direction compared to what was previously being disseminated. So comparing analyses is a bit challenging. In some respects, you have to do a little bit of point verification. Dave, do you have any other comments from the work the analysis and verification team did on this?
Well, the one thing we've done is we've put comparable analyses out there so you can see how it's comparing to other analyses. I think if you verify it versus the NDFT, so you can see how your scores compare. In general, you would hope that a good analysis would come up with lower scores in a worse analysis. When I say lower, I mean lower MAEs and errors. So there are ways like that. There's also cross-validation where you withhold some points and then you go in and see how you've done at this withheld points and go in analysis. And then steps to doing that with the RTMA and IRMA.
Okay, thank you. John, do we have
no additional questions?
Okay. Other questions in the room? Well, I have another one. Could you describe what is envisioned or already taking place with the Weather Prediction Center's value-added piece to the blend? Acting Deputy Director of WPC.
Yeah, no, that's a good question. I think we're hoping that WPC will make sure that the fields are meteorologically consistent. So maybe when you're doing things objectively, I don't know how much consistency checking we can do to make sure that our temperatures and our winds and our precipitation, for example, our inter-element consistency is all there and that it makes sense meteorologically. That would be an area where we expect that WPC will be adding value to consistency checking. We also, I think, expect these techniques may dampen some of the features a little bit, and so we would expect WPC to be able to come in and push those extremes out a little bit as well. Those are two areas I can think of right off the bat.
As a follow-up, when you say that WPC is going to be looking at the meteorological consistency, are you talking about this as a human looking at it and saying, does this make sense, or are you talking about automated techniques to go through and check that your temperatures and dew points are?
It's more at the human side of it, so that the forecasters will be looking at it.
seems like to me in the checking like this that one thing you could do is not try to change things, but just to point out to the forecasters that this is a questionable area. I mean, you're kind of riding over the top of this, right? And you're kind of trying to say, well, this is good, this is bad, and so on and so forth. So if you point out to them that this seems like a questionable area today because...
Well, no, that's true, and that is part of the reason that we're struggling a little bit on the issuance time, because we want to build in a collaboration window between WPCs and the WFOs where they both have a chance to look at this guidance, and WPC has had time to go through it and think about areas that maybe could be improved by the humans and have those conversations with the WFOs. So we are building the vision plan has a collaboration window in there.
To get back to the hydrology question over here, and to Bruce, so any kind of a weighting scheme like this works pretty well on a fairly normally distributed thing, but any time you get out of that, then it doesn't work too well, and of course the worst is probably wind, but it's not the only one, right?
Right. But I mean, I agree. It definitely, this type of statistical scheme will give you the overall lowest mean absolute error in a very overall general sense. You may need human intervention in any particular case to ensure that the forecast you're making makes sense.
So another thing, two other follow-ups. I think it was implied, if not explicit in the slides, so the AWIPS piece is being attended to and is under the blend team, right? So that when the WCOS products start flowing, et cetera, then the forecasters in the field will be able to seamlessly and transparently use GFE to, as they have been doing, to prepare their NDFE inputs?
Yeah, that's the idea. So we've been playing around, not playing around necessarily, but we've got the data packed up in Group 2 for a couple of fields right now. So we've had some early testing, sending those grids out, making sure that the PDFs that we've used to pack the Group 2, for example, make sense. We have gotten this on the abstract list with Ed Mandel so that it will be ready in December. So we haven't gotten test grids to Ed yet, but that's coming up in the next couple months. We need to do that so that it's there and part of the build by December 2015. So it will be in AWIPS. AWIPS 2, thank you. The WPC piece of it doesn't really change because that's their medium range gridded guidance anyway. So that'll go out as APC guide.
Another follow-up I had was on the shorter range projections, which are not part of the current project, but obviously are of high importance down the road.
Right.
And it would seem that on the consistency issue, those are even more important and more evident and problematic in those shorter projections. So it will be interesting how quickly you can get to those shorter projections and start tackling those, because that may be that, and that's really the area where the forecasters probably now are spending the most of their time, right, in editing grids in the 0 to 3 days range, right?
Yeah. So future efforts here, once Sandy supplemental funds run out, we'll be going to the portfolio leads. We've talked to STI, we've talked to AFS about what the future stages of this project might be. So certainly focusing on days 1 through 3, adding in the mesoscale models. But another piece of it is really producing probabilistic products. So that's another area we need to explore more fully, which is we're using all this ensemble data, but yet early on the output is mostly deterministic. So we want to expand the scope of the project with future releases to focus on the uncertainty information, the probability guidance that we can generate from all this model data. So there are a few areas that we want to expand.
Thank you. John, do we have any other questions? In the room? Well, I want to thank again Kathy Gilbert and Dave Myrick for an excellent presentation. And as I said at the beginning, the recording of this will be uploaded to the VLab Forum website shortly after this, and the slides are already there. So if you want to download those and share them, please do so. Looking forward into March, I would say we'll be back here on March 18th with topic is the VLab project portlet, and on May our next topic we don't have anything booked for April yet, but in May we will be getting a presentation on the NOAA Hydromet testbed Southeast pilot study. So please mark those down if you're interested, and join us in March and May, and we'll get something on the agenda for April, I'm sure. So with that, thank you, and have a good afternoon.